super quick video, no messing around. Ideal gases, you know what they are. They're gases that don't have any external forces acting upon them. Everything's elastic, all the collisions are elastic. There's no loss of kinetic energy. You know this, you're doing A-level physics. If you don't know this, learn it, right? But ideal gas assumptions, you need to know them. 3 or 4 marks in your exam, easy marks. Check out the tutorial video and I'll explain what these assumptions are. Okay, let's try and discuss this question. Shorter video, much simpler than our previous video on derivations, but this question says that we need to state the assumptions that are associated when discussing the behavior of an ideal gas, okay? Usually in exams it will kind of ask you for 3 assumptions of the kinetic model of ideal gases, but I'm going to give you 5, and you know, just pick and choose whichever ones you wish, but let's just crack on. So we know that ideal gases are not the same as gases. Okay, we're dealing with a closed system in which no external forces are acting the same way that we are dealing with momentum, right, in a closed system. But the first thing that we can say is that the particle movement is random. Okay, so random motion. Okay, easy peasy. 2 is that obviously collisions are going to be elastic in nature, right? So no kinetic energy is going to be lost in that collision. Okay. Another thing that we can say is that no intermolecular forces are acting. Yeah, which makes sense. If there were intermolecular forces, then obviously we'd be having some of that kinetic energy lost, but that is not the case. Another thing that we can talk about is that the collision time is negligible. Okay, the collision time is negligible, and that is something that we need to assume because we know that the force is equal to the change in momentum over time. And obviously, if we're dealing with a system in which momentum is conserved and kinetic energy is conserved, then we can't really have a significant collision time, right? So the time of the collision itself is negligible. And finally, we can say that the volume of the atom is negligible compared to the volume of the container. Okay, so the volume of the atom is negligible when compared to the volume of the container. Okay, and obviously that is 1, 2, 3, 4, 5 points. Make sure you know 3 of them, and it will serve you well in your exam when you are doing your section on thermal physics. Okay, so again, it's really simple, but you'd be surprised how many papers I mark and I see this question left blank because you haven't bothered to remember the assumptions. They're easy, okay? If you understand elastic collisions in the conservation of momentum, then you will understand this, okay? So go away and learn them. Go away and like and subscribe other videos and this one as well. And I'll see you next time, okay? Bye guys.